Perfect. Okay, so first up, what are we doing today? I've already told you it's Python. We will, so it is important to remember that Python is not something that you can learn in a 3-hour session. So the objective is not of this session is not to make you a pro at programming with Python. However, what we will try to touch on today is one, how do we use Python? What are the basic building blocks which go together in your code to actually bring about the creation of a program which does what you wanted to do? So I previously communicated this agenda over the emails as well. We were looking at a 6.5 hour of total teaching time on Python. I originally planned to spread it over 3 days, 2 hours almost on each day, with 2.5 hours on the last, and the session will be on 21st, 22nd, and 23rd of June. Remember that this is a tentative guideline. So depending on how we go, if you guys are really comfortable, we might be able to finish all of this today in 2 hours. If you guys are struggling, I can slow down and I can explain everything in as much detail as is needed to make sure that everybody stays on board. And so this is the agenda for Python. So as I already asked you guys that if you have Gmail IDs, and all of you said yes. So what we're going to do today is I'm going to skip on the first part, which is the installation using Anaconda. So this is a fairly straightforward process. You just go to this link. I'm assuming most of you are Windows users, or are you on Mac or on Linux? Uh, Maybe someone can unmute and tell me if they're a Windows user or not.
I'm a Windows user.
Perfect. So we have one Windows user,
Oh, Windows as well.
two Windows,
Windows as well.
three Windows,
Windows.
four,
Same, Windows
five.
too.
All right. So if you just go on this link, just to anaconda.com/download. So I'm on a Mac, so it shows an Apple icon. But if you go to this link, it should show a Windows icon. We're not going to go through this step today because I think that it might take up some time. So I will leave it up to you to install it. When you have done installation of Anaconda, it should bring up many icons on your Windows machine. One of them will be a Jupyter Notebook icon. And when you will click on that icon, the interface that will come up will be a similar interface that we will be using today without the installation. Okay, so we're going to bypass this step. We're not going to be doing Anaconda installation. Instead, what we will do is we will be using Google's notebook, which is available on Google Colab. So all you have to do is to type in colab.research.google.com. So when you will open up this link, I have already opened it up, but let me just open it up again for you. Okay, where are we? So an icon like this will come up on your screen. You can still see my screen, right? I'm sharing my browser now.
Hi, I'm just sorry. We haven't received the slides, so we can't click on the link. So is it okay if you could just show it to us again?
Yeah,
Thank
sorry.
you.
So it's called Colab, colab.research.google.com. If you don't want to type this out, just Google the word Colab. So once you click on this, something like this will show up. It might be white in color on your end because I have a dark theme. So it comes as a dark theme on my end, but it might be white. And what will happen is that in your case, since you have not created any notebooks, so this section might be completely empty. All you have to do is to go to the bottom of this and click a new notebook. I think I've already recently created the CompBio 2023 notebook. So if you have to click on new notebook, And when you click on the new notebook, an empty notebook will come up like this. Okay. So the first thing that we have to do is to explore what we see on the screen. When you will start the notebook, what will happen is that on the top right corner, you will get a resource allocation. So what is essentially happening is that you have asked on one of the many thousands of computers available or compute nodes available on Google Cloud, you have requested that you be dedicated a computer, and on that computer you have started a notebook. So after you have installed Anaconda and run this locally on your machine, you will get an interface similar to this. Yes, it will run in your browser. It is a good teaching tool that we employ to introduce new people to Python. And it is also used by a lot of other people. For example, anything that I write in this notebook, I can just go up here, click share, and then enter the details of whoever I want to share this with. Okay, so it becomes a very good collaborative tool as well. So if you have done everything, if you have gone to colab.research.google.com, and if you have created the new notebook, and after this RAM and disk icon appears, then that means that you are now ready to start typing your code into these blocks. Can I see if everyone is good up till here? Are we all on the same page here? So I have 2 thumbs up, 3 people, 3 thumbs up, 2 more, please, 4 thumbs up. Okay, so I'm going to, so everybody's up till, good up till here. So now let's start exploring what we see on the screen. So, well, there's a lot, but like, let me just summarize. So at the top panel here, you have file, edit, view, insert, runtime, tools and help. So one thing that I want to discuss here quickly is the runtime tab. In the runtime tab, you have these few options. If you accidentally run a piece of code which you did not mean to run, or if it's taking too long, what you can do is you can come to the runtime and you can interrupt the execution of a particular block. You can also restart the runtime. So when you restart the runtime, it is as if you have just loaded the browser, reloaded the browser window, right? Restart and run all would mean that you would actually stop whatever you're doing, and you will start everything from the top and go all the way to the bottom, right? You can also disconnect and delete, but basically these are the couple of options that I wanted you to keep in mind. We might need it, we might need them at some point. Apart from this, you will see 2 blocks up here. One of them is the code block, and the other one of them is the text block. I will show you how to use them in a few minutes. To the left-hand side of this is a panel. If you click on these 3 rows that are appearing, you will see a section appear here. We're not going to deal with this section right now. I want you to look at this files section. So in this file section, you will notice a folder called sample data. If you click on this arrowhead, it will expand and it will show you the contents of that directory or that folder, right? So this comes by default to everyone using Google Colab. If you don't see it, that is also okay. The reason why I'm showing you this is because later on, when we will start developing our code, we will apply that code to data held in a text file. So the text file will be available on your computer. And what we will want to do is we will want to move that text file by dragging it and dropping it in this section. so that it is uploaded to the Google Cloud in your Google Drive. And whatever you write in the code block here, it will be able to easily access the file that you have just uploaded holding your data. Okay. So does anybody have any questions up till now? No questions? Okay. So I'm just going to click on this cross button and I'm going to click in the first cell that appears. Okay, so the first thing that I want to tell you now is that there is something called, okay, before we talk about that, when you're writing the code in this Jupyter Notebook, or if you install Anaconda and run Jupyter Notebook in your browser, you are recommended to pay close attention to the do not click refresh. Because if you click the refresh icon, what will happen is that while the code remains safe, you run the code, it has made some progress, it has calculated some data, but if you refresh the tab, everything will be gone. So during our session today, and when you are running it on your Jupyter Notebook on your local machine, do not press the refresh icon. When we are using Jupyter Notebook, we are making use of internet. When you will be running this on the Jupyter Notebook on your local machine, even though it will open up in the browser, it does not require an internet connection. So now there are two icons up here. One of them shows plus code, the other one shows plus text. If I want to run a Python-based command, I will use a code block. The plus means that if I press this, a new cell will get added. So the more I press this, the more cells will get added. Now I've added so many empty cells, I want to delete them. And in each cell to the right-hand side, there is a bin icon that you can press to delete these. But remember that if you wrote a piece of code in this block, and then if you delete it, you won't get it back, right? Unless you have saved, because this is being auto-saved as you go along. There is a way to keep version history, but we're not going to be touching on that. So for now, remember that if you have a code block and if you accidentally press this bin button, for now, you will not be able to get it back. So please only press the bin button when you absolutely know for sure that you're going to delete that block. Okay, so we have a code block and we have a text block. If I add a text block, what will happen is that you will see that this block has a different presentation than this one that we had before. And this block actually gives you text formatting options. So for example, I can do this is a session for a pre-workshop. And what you can do is you can increase text size, you can make the font bold, you can increase the indentation, you can you can include hyperlinks. But remember that what is happening here is that while this appears as text, there is something called markdown. And what happens is that you need a certain way to present the text for it to be rendered. So for example, if I want to write it as simple text, it renders on the right-hand side. If I add a single hash before it, you will notice that the size of this became larger. If I then add second hash, it will be slightly smaller, but it is still larger than it having as a default text. So today's exercise is not about markdown, but the reason why it is important is that sometimes you want to comment your code as you go along. So that if a student is going to be using it, or if you're using it for a teaching purpose, or if you are going to upload it for other users to use. You want to have enough documentation. So what you can do is you can have cells that have a piece of code, and before that cell or after that cell is some explanation of what that block is actually doing. So what I'm going to do is I'm going to quickly delete this and come back to the code block. Any questions up till now? Are we all good? I need at least one yes. Okay. So now what we're going to do is we are going to start coding. And I'm going to start introducing how Python works, what it is, and we're going to go through, progressively go through an introduction to variables. We're then going to move to if conditions, for loops, and functions. Then we're going to go into the reading and writing of data using advanced libraries and using data frames, and then doing advanced statistics, and then finally moving to plotting. So for today's exercise, we're going to, because I'm going to start with the introduction process, I want you to pay note to this play icon. So what will happen is that when you install Jupyter Notebook on your and run it on your local machine, you will not see an icon here. What you will see are square brackets. Those square brackets will appear empty when the block in which you're typing the code has not been run. When you run the code, so for example, a equals 2. This is a very simple declaration. What I'm doing is that I'm creating a variable which is called a, and I'm assigning a value of 2 to that variable. Now, if I press the play button, you will notice that a tick mark online appears next to it. When you do it on your Jupyter Notebook on your local machine, the square brackets will have a number appear in them. It is important to pay note to that number, and it is important to remember the order of execution. So for example, if I write a piece of code in the first line and then modify that same piece of code in the second line, but I come back and run the first line again, it will overwrite the second line. So I will show you what I mean by this. So what I have done is I have created a variable called a, given it the value of 2. And now if I say, what is the value of a? So if I just type a and hit enter, it will print out the number 2. What this means is that the variable a is saved in the Jupyter Notebooks or this notebook's memory, and it is being called and displayed that the value of this variable is 2. If I now think that a should have a value of 3, if I run that block by either pressing the play button or using shift and enter together on my screen, I would have created a variable a and given it the value 3. So what is happening in this few lines is, first I'm creating a variable and giving it the value 2. Then I'm changing the value from 2 to 3. So if I now say what is the value of a, it will display it as a equals 3. Okay, so let me ask it again. What is the value of a in this cell again? And it displays 3. If I now go back all the way up, notice that the numbers that are appearing here, they are in sequential order. So the number in the first one is 1, the second one is 2, the third one is 3, the fourth one is 4, and the fifth one is 5. If I now go back all the way to the top, put my cursor in after 2, and now if I hit shift enter or run the block, you will notice that that block now has the number 6 in square brackets before it. So what does that mean? That means that if I come to the bottom here now, and if I ask it what is the value of a, it will display that the value of a is 2. So you have to remember that when you're writing your code in Jupyter Notebook, what is the order in which the commands that you are running? Mostly what happens is from the top to the bottom, people progressively think that the last command is at the bottom. But if you accidentally go back up and run the same command up there, it would have overwritten the values. Okay, so when you're at the bottom here, what will happen is that A is now getting the value 2 and not 3 because you ran these cells out of order. You ran the first one again and it overwrote the value. Now, this is a very simple case and we caught the error. But sometimes students make this mistake that they run the cells out of order and they end up getting the wrong value. So please keep note that if you're writing the code in a certain progression, make sure that that progression is followed and you don't run the cells out of order. Okay, so this was a very simple thing to keep note of. I'm going to remove all of these cells now. I'm going to go back to the top and I'm going to create a new cell, right? So I'm going to take maybe a few seconds break. I'm going to see if anybody has any questions or if we're all good up till now. All right. I got 2 thumbs up, 3 thumbs up.
Sorry, can I just ask a quick question? What if you
Sure.
run a code 2 times? Or so, for example, just now, if you run your first line twice, it became number 6. And then if you run it again, it becomes number 7, right?
Yeah.
So
So
can
yeah,
you like
exactly.
run? Yeah.
So for example, you're asking A equals 6. If I run this, what will happen? So notice that because I did not interrupt this line, even though the line is at the very top, I still have the number 8 appearing, which means that 7 blocks or 7 execution cycles were run again. If I run this again, which is what your question is, it will now get the number 9. And the more times you run it, it will keep incrementing by 1. Does that answer your question?
Yes, it does. So so that means we have to be aware of the comments when we want to get our final answer. Is that what you're trying to say?
Yes, so there is something called good programming practice, which comes with time. And what I mean to say is that you have to have informative variable names. So for example, if I write a 1000 line code and I'm
Yeah.
declaring A equals 6, B equals this, C equals this, now these variables are not informative. What I should be able to understand is that at what point of the code do I need what variable so that I don't accidentally overwrite a previously declared variable, right? And so that helps. And most of the time when you become a pro programmer, you will, I mean, I don't use Jupyter Notebook. It is a tool that we only use in when we're teaching. And this is a common mistake that students or people who are beginning out, they usually make. When you write, like proper code, what you will be doing is that you will be using a more advanced developer's environment. So, this is one kind of an environment, and there are many others. So, for example, you can use something called Eclipse. You can also use something called PyCharm. You can also use something called VS Code. So all of these are environments where you write your code line after line, and the entire code runs in one block. You do not have blocks like we have here in Jupyter Notebook. Your code from the start to the end all runs in one cycle, right? So this numbering scheme that I introduced to you, the one in the square brackets, is only for these 7 sessions or whenever you're using Jupyter Notebook actually to keep in mind. Does that make sense?
Yes, thank you so much.
No worries. Does anybody else have any questions? Okay, so while I've shown you some execution, it's now time to start thinking about your, oh, by the way, one last thing. What I'm going to do is I'm going to just demonstrate that if I have A equals 6, if I run this now, it's going to be 10. But if I go to runtime and restart runtime, I would not recommend that you do it, but you will notice that up here, you are restarting everything. So now if I run A equals 6, it will have the number 1. So whatever I did in the code before, all the data that was created or saved in the memory, that's all gone now. So having said that, what I'm going to do now is I'm going to start with the actual programming now that we have all of these things out of the ways. So we're going to touch briefly on variables, data structure, and data structures right now. So let's start off by, I've already given you a very simple example, right? So the simple example was that if you have a variable is anything that you create and you assign it a value. Now the value can come in two shapes. One is that the value can be a mathematical number, like we did a equals 2. A value can also be a string, right? So actually, maybe I shouldn't have done that. Maybe I should create a new variable name. So I have created two variables here. I've created a equals 2 and I've created b equals CompBio. Okay. So one thing that I want to introduce at this level is that while you're creating variables, there is also something called data type. Okay. So the data type at a equals 2 is an integer because it is a mathematical whole number. We also have a data type called strings, and I will introduce you how to find out what the data type is later on, but I just wanted to quickly touch on this right now. So if I now say a plus 2, who can tell me what will be the answer? This is just algebra. So does anybody want to hazard a guess? The answer is 4. That is correct. So if I do a plus 2, it will give me can only concatenate strings, not int to string. Wait, what? Why did it say that? I was supposed to say a plus 2. Okay, maybe I'm making a, so see what I'm doing here? Who can tell me why is this error coming up? Okay.
Is
So what
2 not a value?
No, 2 is a value. So what I accidentally did was that when I created the CompBio variable, I first put it a equals to CompBio, then I did b equals CompBio. So the value of a right now is not 2. The value of a is CompBio. So it's a good thing this happened because this also demonstrates that because I was not keeping track of what I had run, I had overwritten my own variable, and now I was trying to add CompBio to 2. And the error is something that I wanted to explain anyway, is that when you have different data types, so 2 is a math number. So let me just run this cell again so that I don't make a fool of myself again. So if I run a equals 2 now, so now you will see that it prints out a equals 4. Okay. So a equals 2, print a, or just let's remove print. Let's just do a plus 2, and it prints out prints out 4. Okay. So the number 2 is integer data type, and only integers can be added to integers. Okay, so if I do b plus 2, what do you think will be the error? Anybody wants to hazard a guess?
The same error you had just now.
Yes. It will say that, Ashar, you're being stupid. B can only concatenate string, not int. So what does that mean? What do you think is this error telling you?
B is a string, not an integer.
Yep. But why is it saying concatenate? Okay, so let me spin this problem around. In maths, b plus 2 or a plus 2 or 2 plus a should give me the same answer, right? So if I do 2 plus a or 2 plus b, what do you think the error will be? I will run this. and I will show you. Okay, so what is the difference between b plus 2 and 2 plus b? The error over here is this, and the error over here is this. So what do you think is happening?
Is it that it recognized the first one? So the first error is saying that it can only combine strings with strings.
That is excellent. Yes, that is exactly what it is doing. So there is in maths, if you do 2 plus 3, or if you do 3 plus 2, or if you do a plus b or b plus a, the answer will be the same because both are numbers and both are being added together. In this case, in Python, it picks up that the left thing that you are trying to pick up, which is b, what is its data type? So the error message says that, so concatenation is that you append one thing to another. So if I do b plus b, what do you think the answer will be? Anyone?
CompBio.
That is correct. So if I do b plus b, it is concatenating. So on strings, the operation of addition just connects the two things together. So the error of can only concatenate string to string meant that it picked up B, it found out that it had strings in it, or its data type was string. So then it said that, oh, Ashar, you're being stupid. I cannot add 2 to this because there's a problem here, because the second data type is an integer data type. In the second line, it picked up the number 2 first. It said that, oh, this is a number, so B must be a number. But then it finds out that no, B is a string. So then it prints out that, hey, the operation of plus can only work on ints. It cannot work between int and a string. So does everyone understand what's going on? Perfect. Can I get one other person to say yes? Okay, one other person. So maybe how Abidi, okay, perfect. All right, thank you. So, okay, so what have we found out up till now? We saw that we can declare a variable. A variable can have any name. Then we can assign a variable a value. A value can be an integer. A value can be a string. Integers and strings are two different kinds of data types. Now, I just said that a variable can be anything, but that's not true, because a variable must be either alphabetical or alphanumeric, but the number cannot come first. So if I say 0 equals 2, I cannot do this, right? In algebra, you don't do this. You do A, B, C, D, E, F, G, whatever, right? So I must have A equals 2, but I cannot start the variable name with a mathematical number or with an integer number. So I cannot say 8A, because if I say 8A, it says that there's a problem here. Okay, I can do A equals 2. I cannot have the variable name starting with a, I can do A8. A8 will work just fine. Okay, and then I can say what is the value of A8, and it will give me 2. But it will not work if the variable name starts with 8. So we're all good. This part, okay. So the next part that I want to talk about is that I introduced two kinds of data types, integers and strings. Now, another kind of data type is something called a floating point, right? Or a float, basically. So you will notice that when I was using A equals 2, what I was doing was I was essentially creating, so 2 is an integer, right? It's a whole number. But in Python, 2.0 is different than 2. And it is just the way how numbers are saved in your computers or represented in your computers, right? So 2.0 is, it looks and behaves the same as 2, but for a computer, it has a different data type. Okay. So I want to demonstrate this using an example. So if I do a equals 2 again, and if I say a plus 2, what is the answer going to be? I would need an answer from someone.
4.
4. Yes, that is correct. Right? But what if I type a plus 2.0? What do you think the answer will be then? Come on. It's very simple.
Arrow.
4.0.
Yes, that is correct. So how you were going to say the same, or maybe? Okay. So if I were to run this, you're right. The answer will be 4.0. So why is it that 2 plus 2 equals 4, but 2 plus 2.0 equals 4.0? Why is it not? Why is this not 4? So to answer that, I would just simply introduce the concept of precedence. So there are some things that are higher than or are given more priority. Think of that. I'm trying to explain it in simple terms. So if you have mathematical numbers, some of them are integers, some of them are floating points, and if they're all interacting together, the answer will be listed in a floating point because Python thinks that floating points have more precedence than integers, right? And that is why the answer over here is 4.0 and not 4, because one of the two data types was, if both the data types are the same, integer plus integer will give you an integer. But if one is an integer and the other one is a floating point, the answer will be a floating point. Okay. Now we're going to quickly build on this. And what I want to demonstrate here is that we did not save this into a variable. So if I do something and I don't save it, it gets displayed on the screen, but then it's lost. So what I will have to do is I will have to do a equals, right? So now if I do what is b, it will give me the same answer as 4.0. Okay. So now we're going to quickly look at some division operations. So who can tell me what is 6 divided by 3?
2.
Is
Two.
it 2 or is it 2.0?
2.
So these are not things that you have to remember. Just remember that there are data types, there are precedences, there are operations which may convert between data types. There are, so if you would have done this in an older version of Python, maybe 6, 7 years ago, in 2, for example, then you to get 2.0, you would have to explicitly declare one of the data types. But now you don't have to. Okay. So just some minor things to keep note of. When you're programming, sometimes these things are important too, because when you're working with values which have important data after the decimal point, then it's important. For example, if I say 6.4 kilometers and 6 kilometers. So the 0.4 kilometers is basically 400 meters. So 400 meters, if you ask me, I would like to know, because if it requires walking, I would like to be prepared beforehand. So if you just tell me 6 kilometers, and then if I have to walk the 0.4, so there 400 meters is important. So 0.4, so the data after the decimal point has value. But sometimes when you're talking about 30 billion kilometers, right? So the number is already so big that if you write out 30 billion in all of its integers, then the value after the point does not have enough significance. That is what I'm trying to say. So depending on what you're doing, the floating point may or may not have importance. So just keep that in mind. We will come back to this when we are working with actual data. So for today, we're just introducing variables and data types. So does anybody have any questions up till now? Anything that you want to ask, clarify? It is important that you understand this very basics, because it is going to get complicated very quickly. And I'm spending time here because if you get the foundations right, it will be easier to understand what comes later. So if there is even a shred of doubt, please do not hesitate to ask any questions. Okay, so I'm going to assume that everything is good. So we have covered three things up till now. We have covered a variable. We have covered what are the important things to remember when you are creating variable names, that the number cannot be at the start, it has to be at the end. We also noted that there are data types. We saw that there is an integer data type, there's a string data type, and we saw that there is a floating point data type or a float data type, right? We discussed that floating point numbers and integers, if they interact, the floating point number gets precedence. So now I want to introduce the concept of lists or arrays. But before doing that, I want to circle back on the B equals CompBio, right? So if I type B here, it gives me, oh wait, I overwrote that variable here. So I have to declare that variable again. CompBio. Okay, so if I do B equals now, so in very simple terms, there are certain properties that get associated with certain variable types. So what do I mean by this? So when you create a string, for example, so I created a string here called B equals CompBio, right? So what I can now do is I can do length of A. So we will cover this in a lot more detail in one of the later sections when we talk about functions. But this is a built-in function, so I will like to do it. I will like to use it here. So just to quickly, can someone tell me what length of B would return? Come on, there are no wrong answers here. Well, actually, there will be a wrong answer, but what I want to do is I want to encourage you to take a guess here. So who will take a guess? Eo,
7.
Jasmine. 7. Why is it 7?
There are 7 letters in CompBio.
That is correct. So if you have length B equals 7, length B, it will give you 7. That is perfect. So now if I do, so what was A? A was 2. Let's say A equals 2.0. Okay. So what is A now? A equals 2.0. So who's gonna, so except for Elson, can someone tell me what length of A would return? Sorry, Elson, you already had your chance. So maybe someone else can take a guess at this, please. I just want to make sure that everyone is listening at least.
Wouldn't it give an error? I don't know. I'm not sure.
Okay.
I got
so
an error too.
Oh, you're already doing it with me.
Usually used for the
Okay.
strings.
Yes. So length of A would not return because the length thing only works on strings or arrays or lists, basically. So you need to have more than one member, right? But the A variable has a floating point number, which is one number. So it can't have a, so it's not a list, it's just a variable. A variable is also called a scalar, right? So length of B works because it is a string and strings can have lengths, but integers or floating points cannot have length. Okay, so what we have done so far is that we know that integers and floating points are different data types. We have seen that strings is one kind of data type. Now what we're going to do is we are going to scale this. We are going to go one step up. We are going to create an array or a list, right? So the word arrays and lists I'm going to use interchangeably, but later on I will tell you what the difference between the two is. Okay, so the first thing is, how do you create an array in Python? So I'm going to overwrite my variable a. So if I do this, a equals square bracket open, square bracket close with nothing in it, I have initialized an empty array, right? So if I then do what is a, it will just display that it is empty. Now, actually list, let's call it list, or let's just, I like calling it array because I work with arrays. So I'm just going to keep using the word array. But right now, lists and arrays are interchangeable. They are different in the scope, but when we come to the difference part, I will show you that. For now, just call them arrays. So I've created an empty array. So now, what do you think length of a will return? I mean, if you do it, that's good. But if you are not doing it, you can take a guess and tell me what length of array would be. Anyone take a guess, please?
0.
0.
That is excellent. So why is it 0?
Because
No,
it's empty.
nothing inside.
Perfect. That is good. That is excellent because there is nothing inside. We have just initialized an empty array. So now the question comes in, what is it that we can put inside these arrays, right? So obviously an array is a higher data type, or sorry, it's a data structure, right? It is, so a variable is the simplest data structure. It is the simplest way in which you can have data, which is directly to have a variable called a and give it the value of 2 or 2.0, right? This is a variable. It is a very simple data structure. Now we have gone one step up and we have started looking at arrays, which is a slightly more complicated way, which is a slightly more higher level data structure. Okay, you don't have to put too much stress on these words that I'm using. Just go with the flow, and as long as you understand everything, it's perfectly fine. Now, because this is a data structure, what we can do is we can put data in it, right? So what are the three kinds of data that we have looked at so far? We have looked at integers. So let's put in 2 integers here. So if you put in 2 integers, in order to how do you tell the array that there are 2 elements in it, right? So you're going to tell the array that there are 2 elements by putting a comma between your 2 values. If I do a equals this, and if I then do what is a, it will print this out. If I now do length of a, it will print out 2. So what is the length of a telling me now? That there are 2 elements in the array. All right. I hope everyone is clear up till here. What I'm going to do in the next step is that I'm going to make an array of floating points. So 5.3, and we're going to do 6.7. Okay. If I now check what is a, it will tell me 2.4, 5.3, 6.7. If I then do length of a, it will tell me that now there are 3 things stored in here. Might have forgotten, but yes. So remember that I told you that lists and arrays I'm going to use in like analogously, but what we are working with here is basically a list data structure. And when you do type A, it gives you the type of that, whatever A is, it gives you its type. If it were an actual array, which we will create later using NumPy libraries, it would have shown you array data type, right? If this also works, or I think it should, if you had a equals 2, and then if you do type a, it will tell you that it is a integer data type. If you change this to 2.0 and then run this, it now shows you float. So what we have now seen is that type can be called onto anything in Python, and it will tell you that that particular variable, is it an integer? Is it a floating point? Is it a list? Okay, coming back to lists, what we're now going to do is we are going to create a list, but instead of putting numbers in it, we are going to put strings in it. So this comma is comma a session. Okay, I've just created an arbitrary list. If I now do length of A, it gives me 4 because there are 4 members. How do we know there are 4 members? Because there are 4 entries and they are separated by commas. All right. So now what we're going to do is we are going to do type A. It still tells you that it's a list. So when you are working with lists, if the list has this type, or if the list has this type, you will still get type as list. Okay, so that gives me an idea. Can I mix data types? What do you think will happen if I mix up this and the number 2.0? What do you think will happen? Can someone tell me? No? Yes? Maybe?
It's still a list.
It's still a list, that is correct. So what is going to happen is that you're going to have constructed a list, but the individual elements of those lists still retain the properties of their data types. So for example, this has a data type of string or character data type, as it's also called, and 2 has a floating point data type. So up till now, so if I do type just to show, it still comes up as a list. Okay, so I told you that as you go up in your data structures, the data structures come with more powers, right? So now that you are mixing up 2 data types, there are, and you looked at the function len, which showed you what is the length of that list. You can also now start doing something called indexing. Okay, so like if you are living in a housing colony, for example, you enter the colony and you have house numbers, house number 1, house number 2, house number 3. And as you go through the colony, you go from house number 1 to the house number last, right? So think of this array as a colony. You start off that the address of this is 0 and the address of 2 is 1. So the indexing basically, or the addressing mechanism in Python, gives the address of 0 to the first element. Okay. So why is this helpful? Because let's suppose that I want to call out the first position element from A. What will I do? I will say A square bracket open close, and then I will put the number 0 in it. If I do this, what does it return? It just gives me the first element, right? So this 0 basically corresponds to the first element. If I replace 0 with 1, it gives me 2.0. Okay. Now I told you that even though we are mixing data, can someone tell me what the answer of this will be? A square bracket open close with 0 inside plus A square bracket open close with 0 inside. What do you think will happen when I run this cell?
Error?
Why?
It's string and a number and float.
This.
Yes, that is correct. So it will give you this, because A0 is also pointing to this, and this A0 is also pointing to this.
Oh, okay.
So it will give you this. This is the same thing that was happening when we did B plus B. Okay. It will give you an error if I do this. I mean, I should not have used the word this inside because then it's confusing. So if I run this command, A0 to 1, you get the same error back. So what is this telling you? This is telling you that even if you were able to have one variable have a list which had mixed data types, even after the mixed data types were put inside that list, they still keep their data types. So later on, any processing that you do, it will only work if the same data types are interacting with one another, right? So in my opinion, I don't do this, and I would also recommend that you do not mix data types. Sometimes it is a necessary evil, but for most times it can usually be avoided. So I would recommend that you avoid it. Okay, so I'm going to take like a 2-minute break. Does anybody have any questions up till now? Is everything good?
No.
Okay.
Yes.
All right. Okay. So we saw data types, we saw data structures, we saw creating lists, we saw how to get one element out of that list. Okay. So in terms of our schedule, where are we right now? So we have covered lists, arrays as data structures, and we have covered variables, right? So from this point onwards, what is going to happen is that I'm going to slightly speed up because I want to show a lot of things. And what is next anyway? So what is up next is if conditions. So because I want to demonstrate a lot of things, what I will do is that I will speed up. If you get stuck or if something does not make sense, please do not hesitate to stop me. It is very important that you know at this level, because later on, when we're working with more complex code, if you're struggling with these concepts, it will be harder to understand the structure of the code. So do not feel shy. Please interrupt should there be anything that might be confusing. Okay. So from this point onwards, we start with if conditions, right? So most of the times, what is happening with programming languages is that you want a certain piece of code to run only if some condition becomes true. So an example of that would be that you see that street lights turn on in the evening hours. How do they know that? How do they do that? So in programming logic, it's a simple thing. If natural light is below this level, turn on street light, right? So you're continuously measuring the light, and if the value of the light falls below some threshold value, you trigger a certain piece of code. So what I'm going to do now is I'm going to show you how to achieve this effect using Python. Okay. So the first thing that we need to do is we need to understand the syntax of the if condition. Before I introduce the if condition, I want to explain to you something called logical operators, because they are extensively used when we're working with if conditions. So for the next couple of minutes, let's look at logical operators. So if I say 1 greater than 0. Can someone tell me what the answer of this is going to be?
True.
Yes, it is true because 1 is greater than 0, right? So the greater than sign over here is a checker whether the left-hand side is greater than the right-hand side or not. If it is, it returns true. If I were to flip this, it would return false, right? Very basic stuff. All good? Similarly, I can flip the sign around and do is 1 lesser than 0? The answer is false. Then is 0 lesser than 1? The answer is true. Okay, so now we're going to build on this. So the next step on this is, so you have checked lesser than equal to or lesser than. We want to see how we can compare if the two things are equal, right? So is 0 equal to 0? The answer would be true. So you don't use 1 equal because 1 equal is the operator that we're using up here. 1 equal operator is when you are assigning to the left-hand side whatever is on the right-hand side of the equal. When you use 2 equal to signs, then that means that you're comparing. So 0 is equal to 0, 1 is equal to 1, but is 1 equal to 0? No, it is not. So it will return a false, right? Now, the next thing is that what if we want to check a certain condition that is beyond this, what I just demonstrated. So is 1 lesser than equal to 0? I mean, is 1 greater than equal to 0? So what is the answer? True. Can someone explain to me why this is true?
Because 1 is greater than 0.
Yes. So when you combine the conditions greater than, equal to, it will work out. If you do 0.1, what do you think the answer will be of this? If I run this, what is the answer going to be?
True.
That is correct because 0.1 is still greater than and equal to 0. So if I put 0 here, what is the answer going to be?
True.
If I now do -1 or -10, the answer is false. Okay. Now you might ask, why are we doing this? We already know that. Why do we have to combine greater than and equal to conditions, right? So most of the time, when you are programming, you do not know the values. And we will see later on when I'm demonstrating that there comes a point in your programming structure that you are just checking conditions, but you don't know what their values are. So for example, if the sunlight during the day hours is being measured in, let's say, units from 0 to 100, and your threshold is set to 50, then on one side of this comparison operator, you don't know what the value is, right? It is coming from a sensor. The sensor is being exposed to the sun. It might be reading 78, it might be reading 32, it might be reading 51, it could be anything, right? So and then you want the value to be compared to your threshold, and maybe your threshold you set to 50, that at 50 we have determined that the visibility is so low now that we want to turn on the street lights. So then you will say sensor light value below 50 should execute this. So we want to get these true false comparisons for that block or that condition to work out. Okay, so that is where we combine these operators. Now, there could be more operators. So for example, you could also have this the other way around. Is 1 lesser than equal to 0? The answer would be false, because 1 is not lesser than and not equal to 0, right? So you have these things, and then you have something called not equal to. So for example, is 0 equal to 0? The answer is true, but if you do 0 exclamation mark equals 0, the answer is false. This condition will be true when the two things that are being compared are not the same. So if I do 1 is not equal to 0, the answer will be true. If I flip this around, if I say 0 is not equal to 1, it will also be true. But if it is 1 not equal to 1, it will be false. Okay, so we've looked at these operators. We have looked at that these operators, they return true false values, and true false values are what we need to trigger if conditions. Okay, so what we're going to do in the next step is we are going to start constructing if conditions. Actually, I just recalled I should explain one more thing. What do you think will happen if I compare comp greater than 0? What do you think the answer will be to this?
Error. Error.
Is it? What does it say? I mean, the error is quite obvious, right? The error says that you have different data types across the two. You have two different data types across the operator, and they're not. There's no support for this. But it is important to remember that in some programming languages, this check is not there. So what happens is that comp will get converted to a number, which might be some ASCII representation of the numbers of the string, and that ASCII representation will get converted will be compared to 0. So what I'm trying to demonstrate with this is that while Python has checks, in some other programming languages, you may not have these checks. So it is all, as a rule of thumb, it is always important to know what data types you're working with, what are the operations that are supported on those data types, and do not try to be stupid like me right now and do something like this. Okay. Okay, so now we start working with if conditions. Can I take a pause and ask if somebody has any questions? If anything is not clear, please ask. Otherwise, a thumbs up would be good.
Can I ask one question? So if I try the comp not equals to 0, it gives me an answer that's true. So if I put a string that's not equal to like a different data set, it will be able to give me a yes or no answer? Like true or false?
So, okay, I'll be honest here, and I will say that I have not explored all these possible combinations. As a rule of thumb, you should always have the same data types being compared, right? Because integers can be compared to floats, and floats can be compared to integers, but you should not do it across, because right now, does this work? Yes. What will happen when this happens? So in my mind, if I say that, oh, comp sometimes work with 0 and sometimes does not, I have a tendency to start replacing all of these operators with each other. And then this does not make sense. So in short, I don't know the answer to your question that which data types across what operators can work and cannot work. But I will definitely tell you that do not try to have different data types across the operators. Does that make sense to you?
Yes, thank you.
All right. So, any questions? Are we all good? Okay. So next comes up constructing if. So surprise, surprise, to construct an if condition, you just write if followed by the condition. So if you don't, right now, we don't have a condition. So I'm just going to type true, and then I'm going to type the colon mark. So at this point, when I hit enter, you will notice that there will be a slight gap between where my cursor is blinking and the start of the line. At this point, I would like to introduce something called indentation, which is what this is, the gap at the start of the line. And I would like you all to remember or keep in mind from here on in that Python is an indented language. What does that mean? That means that in certain cases, we'll be using if conditions, functions, and for loops. When you start constructing these three things, you have to keep in mind the indentation. For example, if I go to the start of the line by pressing backspace, whatever I type here will not be a part of this if condition. It will be interpreted independently of the if condition. If I want it to be true only if the condition is true, then it has to be indented. Okay, we will explore this more as we go on. So what I'm going to do is, as a test, I'm going to start and put a value of 2. I'm going to say if true, change the value of a to 3. And then in the next cell, I'm going to say what is the value of a, right? So actually, maybe this is not such a good idea. What I will do here is I will do, I'll just leave a here. Okay. So if I start by declaring a equals 2, then I change the value. If the if condition is true, then a will be 3, and then print the value of a. So does everybody understand what is happening in these 4 lines? If you don't understand, please unmute and ask.
Sorry, I don't understand.
Okay, so I have created an if condition. So when I start to create an if condition block, I need to use the characters if followed by a condition. If that condition is met, whatever is in the block will be executed. If the condition is not true, that block will not be run. So right now, I'm not using any of the conditions here. I am directly saying if true, which means that this will be true 100% of the times. Whenever this if condition is run, it will always be true, which means that this line will always be run and a will always get the value of 3. If I replace this true with false, and if I run this, the value of a is now 2. No matter whatever I do, because the if condition is hard coded with the word false, it will always not be true, and hence will never run a equals to 3, and then a will retain the value of a equals 2. Does that make sense to everyone?
Yes.
Perfect. Everyone else? All right. So now this was a true false statement, right? So what we're going to do is we are going to now replace this false with a condition that we were looking at before. If 1 is greater than 0, a equals to 3. Otherwise, a will retain the value that it had before. So is 1 greater than 0? The answer to that is
True.
true, right? So then that means that when I run this, the value of a will be 3. If I were to flip this around if 1 is lesser than 0, is that condition also true? Is 1 lesser than
No.
0? Yes. So if the answer to that is no, then that means that 1 lesser than 0 will evaluate to the word false that I had written here before. And if I now run this, the value of A will be 2, as if this block never ran. Okay, which it did not, basically. So this was very simple logic. We created an if condition. Now what we're going to do is we're going to complicate it. So let's take a real world example. Let's say that Ashar gets Ashar scores 80 out of 100. Okay. Now I want to assign a grade. Now, if I know Ashar is, so let's create a grading scheme. So I'm going to introduce a comment. Oh yeah, one thing I did not introduce before. If I start a line with a hash symbol, whatever I type after that is not code. It is called a Python comment. So I'm going to write for reference that if I'm going to give a grade, if the marks are between, let's say, 100 to 90 for reference. This is not code. This is just me adding text so that we remember later on what we are doing. If it is 90 to 80, we are going to give it a B grade. And we are going to give it an F grade if it is 80 to or less. So 0 to 80 gets F, 80 to 90 gets B, and 90 to 100 gets A. Can someone tell me what is the problem with this comment? Do you think that this is the correct way of assigning grades?
No, cause 80 and 90 are in two different grades.
Yes, that is correct. So the word 90 is here, and the word 90 is here as well. And the word 80 is here, and it is also 80 here as well. So if somebody scores exactly 80, do they get an F or do they get a B? So this is the same kind of conundrum that you want to avoid when you're programming, right? So you must have non-overlapping classes, right? So now if somebody gets 80, they are definitely getting a B. If somebody gets 90, they are definitely getting a B. If somebody gets a 91, they are going to get an A. Is everybody clear on this? Okay. So now let's try and structure a piece of code that will help us get this. So if Ashar is greater than 100, let's suppose. So I will start off by creating the grade as an empty string. I will say grade equal. So now I'm going to, within each of these blocks of if condition, I'm going to start including what the grade would be. So I'm going to say grade A, actually A plus. Actually, I did not make that. So let me just say greater than 90. Okay. So now comes the part that how do we say, because we have more classes, right? We have 3 classes. So how do we say if this condition is true, then Ashar gets the grade A, but how do we define for B and F? So there we have something called else. Okay. So else does not take a condition as input. Else you cannot say, just like if Ashar is greater than 90, you cannot put if else else this. Whatever is not run in the first will automatically become grade equals F. Okay. So then if I do print grade, the grade is F. Why is grade F? Can someone tell me how this code is working?
Because it's not more than 90, that's why it's F.
That is correct. So how do we get these categories? How do we get B and F in here? So the the if condition also comes with an else if. Okay. So it is defined as elif. I think I might be confusing two languages here, but let's see if it works out. It did change the syntax color. So it means that it will understand this. So if Ashar is greater than 80, no, oh yeah, Ashar is greater than 80, give grade equals B. Okay, so what do you think will happen if I run this code now? What will be my grade?
Still F.
Still F. Can someone other than Elson explain why Elson's answer may be correct or wrong? So how, Jasmine, you, anyone? Do you guys agree with Elson's answer? Will it be F?
Yes. F.
Okay, so why is it F?
Is not great. Is not greater than 80.
That is correct. It is not greater than
Good.
80. So if my grade would have been 81, then it works out. I get the grade B. Okay, but because the value is at this, even though the program does not know what I'm doing, right? So the program only sees these conditions. So maybe I can do greater than equal to, and then if I run this, I will still get a grade B. Okay. Any questions up till now? Because I'm going to ask a very trick question now. So let me just copy this entire thing, post it here. But this time what I'm going to do is I'm going to say greater than equal to 80 up here and greater than 90. I'm going to change this to B and I'm going to change this to A. So what is Ashar going to get this time? Anyone?
B. Still B.
Ashar is still going to get B grade. Ashar is not a good student. So what do you think is the problem with this kind of a code structure that I just wrote?
Ashar can never reach grade A.
Ashar can never read grade A. Yes, Ashar is stupid, but tell me more. How do you think Ashar will never reach A?
If has is higher priority. So if even though Ashar got 95 points, the code only asks you the first line. So you can only reach the.
Yes, that is correct. So it's just not the first if, it is any else if that comes before. So what happens is that whenever the first condition is met, the rest of the code is not processed at all. So let's suppose that we had 30 else if statements in this, and the code would have reached a true condition on let's say else if number 13. It would not have processed the rest. So when the code processes the first if, it exits. So even though this is a better meeting condition, the code will never see it because the code is dumb. So this point demonstrates the importance of understanding what you're doing when you're programming, because if you don't structure your if-else block correctly, what you are thinking might not happen because the code does not know what you're trying to do. The code only understands the logic that flows through the if-else block. Okay. So are we all good up till here? Any questions? Any comments? No. Okay, that was fast response. Okay, I'm actually gonna take a 5-minute bathroom break. So we are going to, so it's 7:32 at my end right now. We are going to meet back here at 7:37 and we will start looking at what is next. So we have looked at if conditions. So we're going to maybe cover for loops as well. Okay. So meet back here at 7:38 now because it just turned 7:33. So 5 minutes, everyone. See you all in 5 minutes. So we still have 2 minutes. Does anybody have any questions? Anybody wants to discuss something? Clarify something? We have 2 minutes. No questions? Okay.
Sure. I got a question.
Yes. Yeah, sure, go for it.
Yes, previously you defined A equals 2 and the following is if A less than 0.
You mean A? Do you mean A equals 2?
Equals 2, and then you give a if condition if 1 is less than 0. I'm sorry, if 1 is less than, and indeed, yes, and A equals 3.
Oh, you mean this code?
Yeah, this code.
Yeah.
How you correlated to each other? Because 1 less than 0 is false.
Yes. Which means.
And you define.
Which means that this line. Sorry.
Okay. This line never using, never execute.
So what I'm saying is that if condition has a structure, any line after the if condition that has this indentation is a part of the if condition. So A equals 3, this line will only run if this condition is met. A equals 2 is outside the if condition. So when I run this cell, A automatically becomes 2. But A equals 3 will only happen if this condition is true. So if I run this code now, it prints 2, which means that A never becomes 3. But if I flip this around, now 1 is greater than 0, right?
Yeah.
So this becomes true, which means that now A will be printed as 3. Make sense?
Okay. No matter what you defined before, it's another code now.
Yeah. So
you switch to another code if.
Yes.
Because it fit the condition if.
Yes, that is correct. That is correct.
Right.
So this is a condition, right? So I used it here. So grade was empty, right? We start grade as an empty string, but we give grade 3 values, B, A, and F. Depending on which condition is met. A, Ashar is greater than 80, then B happens. If Ashar is great, actually this is not correctly written. If Ashar is greater than 90, grade is A. If Ashar is greater than 80, equal to 80, then it's B. So if this condition is not true, which it is not because Ashar is 80, then it goes to the very next condition and it tries solving this. So because Ashar is greater than equal to 80, then grade becomes B. And that is why grade is printed here as B. Does that make sense?
Yes, I got it. Thank you.
Perfect. Does anybody else have any other questions? No? Okay. So we will now move to, let me see, it's going to delete this and delete this and add manifold block. Okay. So we're now going to start working with for loops. I will explain basically what a for loop is. So there are actually two kinds of loops. Looping in Python. So there is one kind of loop which is called the for loop, and there is another kind of loop which is called the while loop. We're not going to talk about the while loop. We're only going to discuss, I mean, maybe if I have time or maybe if the while loop comes up later, we could talk about it. But for now, we're going to cover the for loop only. So what is a loop? I mean, we all understand the word loop, right? So loop is basically you do the same thing over and over again. So why do we need to do the same thing over and over again? Because in most time when you're doing programming, you may have to, you may have a lot of things and you may want to do the same thing for all of those things, right? So we're going to try and build on this concept of doing the same thing for many, many things by looking at the structure of the for loop, right? So I'm just going to remove the while from here, and I'm going to start explaining what a for loop is. But before I do that, there is one, or actually there are a few other things that need to be considered. So when I say a for loop, it means that it has to repeat itself a certain number of times. But how do you tell a for loop how many times it has to repeat? There are various ways of doing that. So we're going to look at a few ways in which that can be done. The first way is I'm actually going to create some variables. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've just created an array of numbers which I have called by the variable a, and now I'm creating another list. I'm creating another array or a list, or I mean Python here. Python is calling it list, so we're just going to stick with that word. Okay, so what I've done is I have created two lists. One list has integers, the other list has and maybe I can mix and match this as well. Let's copy this, put this here, this. So actually I've created three lists now. So list A, list B, and list C. So what I'm going to do now is I'm going to demonstrate how we can tell for loop how many times it has to run. So if our data is present in these lists, what we will do is we will start the for loop by typing these three characters for. We will put a space. We can choose a variable. I usually choose I, J, K when I'm working with for loops. So I'm going to choose I. Then I'm going to type in, and then I'm going to give the one of these three lists here. For I in A, then I'm going to put a colon, just like I put a colon here at the end of the if statement. I am going to hit enter. As explained before, whatever I want to do in the for loop needs to be indented, just like it was indented here before the if, before the grade statement, it has to be indented here as well, right? And I'm just going to type in I. Okay. So you see up here that A has the numbers 1 through 10. So I is going to run over the list A, and every time it is going over it, it will inherit the value that it is on. So if I run this, it is going to print 10 values. Wait, what? It did not print it? Okay, maybe it's the explicit print statement. Yes. So what is happening is that I starts from this number, it goes all the way till 10, and so the for loop basically runs 10 times. How does it know it has to run 10 times? Because there are 10 things in this list. Maybe you think that I'm lying. So I'm going to change this to B now. How many times does the for loop run? This time it runs only 2 times. The first time I gets the value this, and the second time I gets the value of session. I can then change this to C and do the same thing again. So I gets, for the first 2 turns, it gets the value of this session. And for the next 5, it gets 5, 6, 7, 8, 9. Okay. So does anybody have any questions up till now? Because the next step is going to build on this, and it is going to make this slightly more tricky. So any questions before I move on? A thumbs up would be good. Perfect. All right. So now what we want to do is we want to, this was a weird looking for loop, right? We didn't do anything inside the for loop. So what I want to do is so I have an array here. I want every number to be added to, I want 100 to be added to every number. Okay. So that is an action that requires repetition. I want to go to the first element, add 100 to it, then the second one, add 100 to it, and all the way down to the 10th element, adding 100 to it. So how will I do this? For I in A, I know that, for I in A, I know when I do I, it prints out the numbers. So all I have to do now is I have to. So what does it print? It prints out the entries after having added 100 to them. Okay. Very simple, basic stuff. No, nothing complicated here. Okay. So now what we're going to do is we are going, so up till now, what we have learned is that the for loop, this action of repetition in computational terms, it is called iterations. So the for loop iterates over the elements in this list. And every time it is inheriting what that value is. Now, what do you think will happen if I run this same block of code, but instead of having A here, I do C? Can someone tell me what will happen?
Probably error.
Why will there be an error?
Because there are strings in this C.
Yeah. But what if I flip this? What will happen now? So if I run the code now, what do you think will happen?
They
Any
give you
thoughts?
values for the first 5 numbers and then error.
That is excellent. That is absolutely correct. So for the first bunch of numbers where the data type is supported with that operation, it will work out just fine. And then it will start complaining that, oh, so what will basically happen is that it will break when it hits this, and no entry after that will be processed. So for example, if I had numbers here again, it won't be able to reach those because once the code hits an error in the for loop, it breaks. Does that make sense? Okay, so now I'm going to show you a different way in which you can iterate. So there is the built-in command called, maybe I should just, it's called range, right? So one good thing about Jupyter Notebook is that it offers you suggestions of auto completion, right? So, but we're not going to go over that. So when you give it the range function, in the range function, you can specify things. So 0, 10, 3. What this command does is it does not expand, but it does create an iterator. So what I can do is I can use this for I in range 0, 10, 3, print I. So what does it print out? 0, 3, 6, and 9. So the way the range command works is it takes a starting number, it takes an ending number, and it creates, and it also takes in the difference between consecutive steps. So it will start with the number 0, then add 3. So the next iteration will be 3. The iteration after that will be 6. The iteration after that will be 9. The iteration after that will be 12. but 12 exceeds the number 10, so it will stop. To make more sense of this, I'm going to replace 3 with 1, and then you will see that it's incrementing with ones. Note that because indexing or addressing in Python starts with 0, it will not take account of the last number. So the number 10 is not considered, but up till 10 are considered. Does that make sense? All good? No, I can explain again if this doesn't make sense.
Yes, please. Could you explain that again?
Okay, so range is a function that is built in Python. It takes in 3 numbers. I gave the first number as 0, the second number is 10, and the third number as the number 3. The first number is the start, the second number is the end, and the third number is the step difference between consecutive entries. If I choose the number 1 to be 5, for example, it will only print 0 and 5. Okay, if I put the number here as 0.1, it will print probably, oh, my bad. No, okay, it doesn't accept floats. Thought it did, but maybe that's a different. Okay, so if I give it the number 1, it will create differences of 1 and print all the way up till 10, but not including 10. And I will demonstrate this using another example. So can you tell me what is the size of this array? So I'm just going to copy this, or size of this list. So if I do length of A, what does it tell me? 10, because obviously there are 10 members in this list, right? So I explained to you that you can use A0. So what does A0 return from this list? Anyone?
1.
That is correct. It returns 1. So what will A5 return?
That would be 6.
That is correct. So what will A10 return?
Nothing.
So I see other people turn on their mics. So Yasmin, you wanted to say something?
Yeah, I'm not sure. It's
Okay.
A10.
How you said that it would return nothing?
No, I guess it was a bad error or something.
So A10 is not an address of this array because the addressing system stops at 9. Why does it stop at 9? Because it starts at 0. So 0 to 9 is the same as 1 to 10, right? It will have 10 members. So if you start counting 0 as a number, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, those are 10 things. And if you start counting from 1 till 10, those are also 10 things. So because indexing in Python starts from 0, it goes from 0 to as 1 and then goes here to, so the at position 9, if I change this to 9, this would return the number 10. So this is this one. There is nothing after that. So if I put in 10 here, it will say that the index that you are using is out of range. Out of range of what? Out of range of elements that are described in the list A. So why are we talking about this? Because this concept is important in understanding sort of what range is doing. So if I do range 0 to 10 to, let's say, 1, okay? So it does not show me anything, but inside it creates an iteratable object just as a list. And what I can do is I can iterate on it. So if I do actually, let me drop the last comma. Let me just go from 0 to 10 because the default value of this is 1. So if I do this, it prints out the first value it prints out is 0. It will go up till 10, but not include 10. So the last value that is printed is 9. Because 0 to 10 with an interval of 1 needs to have 10 values. But if you include 10, that would actually be the 11th value. So it does not include the last one. Yasmin, does this answer your question? Does this help explain?
Yes, thank you.
Okay. So I now is inheriting these integers. Okay. So what you can do then is that sometimes right now, how do I know what the size of the, so I use the word 10 because I was talking about this array. Where is it? I was talking about this array and I knew that it had 10 elements. But what if I don't know what is the size of the array? So how do I run over all the elements of the array without knowing the size? Can anyone tell me? How would you fix that? Because when you're programming, you don't know how big the array is going to be. So anybody want to tell me how they would do it? No? Okay. So surprise, surprise, there was a function that we used called length of a. So if we do length of a, it returns whatever it returns. And what we can do is we can substitute this number 10 with length of a. And it would still have the exact same effect, but this time you do in your code, you do not need to explicitly declare the number 10. Okay. Now the function that we're using here, range, is flexible. You know that I was using it first with 3 inputs. Here I was using it with 2 inputs, but you can also use it with 1. So if you use it with 1, what you are losing is the capability. I mean, it will always start from 0, but you're losing the capability of defining your step size. Sometimes you do not want to run over every element of the array. You want to run over every second element or every third element, right? So if we wanted to run over every third element, we would have to specify the step size. In order to specify the step size, I would need to use 3 things here, not just 1. So let's come back to iterating for I in A. So if I were to write my code like this, what is happening is that the A array has 10 elements and I becomes the first element, then the second element, then the third element. But what if I don't want all elements? I want every third element. Okay. So what if I only want, okay, let me just for the sake of consistency, what we're going to do here is we are going to change these numbers. So I'm going to add the number 6 before them and maybe drop, we have 7 here, just so that we don't confuse. So right now, if A is an array which goes from 61 to 70, for I in A, print I prints the value of I. Every time it is running over this list, it inherits those elements and it prints out 61 to 70. So what we want to do now is we don't want to print all of these numbers. We want to print some of these numbers, right? So now we are going to start combining the concepts that we've had so far. So what was the first thing that we learned? We learned that if we have a list, we can specify an address. We can say, give me A5, and it will print out the sixth element, which is 66, and display that here, right? So if we want to print only certain elements, we want to be able to specify exactly those addresses. But how do we do that in a for loop? The for loop is running over everything, right? But here we learned the concept that if we do range, if we start the range from 0, if we say the range should be the entire list, but then we want to print out only every second element. So we will define our step size here, right? Now, if I print I, what does this return? What? Oh, sorry, I missed in here. So what is I printing right now? Can someone tell me, please? Anyone?
It's printing in the range of 0 to the length of A, which is 10.
10. Yes, that is absolutely correct. So the length of A is 10. Your starting index is 0. But we don't want this. We want the actual members from this list. So what modification do I have to do with this code for these values, which are addresses, to become these values, which are actually what are present at those addresses? So does anybody want to tell me what that would be? Come on, take a guess. So what did we do here? What is A5 giving us?
Oh, so you replace 0 with A0, tag 0.
You mean here?
Yeah,
What do you want this to be?
A, then square bracket 0.
Okay. So what do you think this will give you? So what is A0?
61.
A0 is 61. What is length of A?
Oh, it's 10.
So what the range will do is it will start with the number 61. It will try to go to 10 with an increment of 2, and the next increment will be 63, and then the code will not give me anything. It doesn't print out anything because this for loop is not executable. So, okay, so we have established that we don't want A0 here. So 0 only is an indexing system, and I is inheriting that index, right? So what did we do here? So what is this? I wrote A square bracket open 5 square bracket close, right? So what is happening in this command? Can someone tell
It's
me?
showing the 6th item in
Yes,
the list
but
A.
yes. So, but what is the number 5 here? What is 5?
The position of your data.
Yes. So what is I here?
The positions as well.
It's the position. But I
Yeah.
want the value at that position. So when I wanted the value at position 6, what did I do?
Square brackets and then 5. So you can put square brackets and I.
Of course you can. But how will I do this? Somebody needs to tell me how to do this. So how will what do I write here so that these numbers become these entries? Just like A5 became 66, you are on the right
Oh,
track. So we need square
yeah.
brackets.
So next line, you can put A square bracket I don't know.
A square bracket I.
Yeah.
But why next line?
Oh, the same line. I don't know.
So
just
yeah,
print the A
yeah,
square
Oh,
bracket
print.
I.
Oh,
yeah,
yes.
yeah.
Okay.
Just do that, right? So what have we done now? We have gone through a few different ways in which we can construct a for loop. So we chose, because for loop requires many things to do the same thing too. So you need the for loop for two things. One is telling the for loop how many times it has to run. And the second thing, what it has to do while it is running that many times. So the first line that we looked at, it was telling it how many times does it have to run. The second line does something very plain and very stupid. It just prints the values out. But what I can do is over here, I can multiply it with 90, right? Or I can take the square root. Actually, that would be a little tricky, but I hope this works. Yeah, so you can take the square root, you can take you can raise it to the power of cube. You can do whatever you want, right? But this is a very simple syntax. So for 5 values, it has done something. So does anybody want to explain to me why there were 5 values? How does this control 5 values? So we looked at
Because
this.
between 0 to 10, if you like the stepwise is 2, then you
Yes.
have 5.
That is perfect.
Yeah.
That is all we need to remember. Sometimes I get confused because my arithmetic skills are not as strong as I would want them to be. So sometimes I don't know exactly, but the code will know. So there might be some hit and trials. So sometimes you want only the even values and you don't know how to do that. So sometimes you might have to skip, try out a few details here before you can get the right thing. And obviously, ChatGPT is your friend these days. So maybe in the last lesson, when we do functions, I will also demonstrate how you can use ChatGPT to enhance your code. Okay. So at this point, does anybody have any problems? Because what we have done so far is we have covered variables, we have covered data structures, we've looked at lists, we've looked at arrays, we've looked at if conditions, we've looked at for loop. Next comes functions. So are we all mentally tired? In which case I can leave functions for next time? Or do you think you can hang in there for another, say, 20, 30 minutes and we do functions as well? No thoughts?
I can hang in. I'm good.
Okay, that's one
Same
vote.
here.
2 votes. We're 50-50.
Into from the half hour.
Oh, you can hang around for another half hour.
Yeah.
Perfect. Because, okay, one thing that I probably should have said in the beginning is that programming, the way you don't, I mean, I've been using Python for like 10 plus years, and even I don't remember syntax. So there are some things that become muscle memory. You do it so many times that it becomes a second nature. But when you're doing something new, you always have to revert back to the help manual, right? So the purpose of this demonstration is not that you learn, is just so that you are exposed that there is something called an if condition, there is something called a function, there is something called a for loop. because even most of the time when I'm programming, I'm trying to do something, I always go to Stack Overflow, which is a community where people share their code, they discuss problems that if you want to do this step, this is the easiest way, or this is the most optimized way of doing things, right? And now you don't even have to go to Stack Overflow. You can just ask ChatGPT what it is. So just as a 2-minute break, I will go to ChatGPT and I will ask it to construct. So the thing with ChatGPT is that you have to construct your query or the prompt in a very meaningful way. Okay. So I will start writing, I have 10 members in a list in Python. Please show the, actually you don't have to write please, but yeah, okay. So I'm just gonna remove, show the code to iterate over these 10 members. So if you type your thing like this, notice what it did. It displayed, it created a random list, gave it a name, showed you like how to, so remember that I was using the variable I. So when I was constructing the for loop, I said for I in, so the code that it reproduced is here. So I was doing for I in C. I told you that it is always a good idea to have more user-friendly variable names. So for member in my list, print member, right? So I can also say in the above code, use range to iterate. Now what it will do is, notice that it used my list. It then brought in the range. It said length my list for I in, and then it is doing the same thing. We had our list named A and we had square brackets in front of it. This code is a bit more detailed. It first creates the variable called member and then prints it. We printed it in the same line, right? So this is a very simple explanation of constructing a for loop, and you don't have to remember any of this. The only thing that should be in your mind is how do you go about solving the problem. If you can construct a mental picture or an abstraction of your problem, you can then construct it nowadays in a natural language query, give it to ChatGPT, and you will have your answer. Okay. Does anybody have any questions before we actually go back to doing what we are supposed to do? All right. So now comes the last part of today's thing, and we're going to quickly look at functions. So what exactly is a function? When do you need it? So we looked at if conditions and we determined that you need certain other things to be true or false, and those conditions control what you're going to run. Then we learned for loops, and in for loops we saw that we want to do the same thing over and over again, or we want to do something to either the members of the list or use that to do something else. We raised it to the cube power, we took the square roots, we're doing many things. So we constructed for loops. When do you need functions? So for example, if you're writing a huge piece of code, what will happen is that from time to time, the same kind of statements have to be run over and over again. So what you do is that instead of writing 10 lines and then go a few lines down in your code and repeat the same 10 lines, and then go down a few lines and then repeat the same code, you can actually package those 10 lines into a function, declare it only once, and for all of those times that you needed those 10 lines, you only call that function. So functions are a nice way in which you can condense your code, right? So let me give you an example. So let's say that our objective is to, I mean, a very simple example that I usually use for teaching is that if you have f equals 9 by 5 times c plus 32. So this is a formula for converting centigrades to Fahrenheit, I think. But let's suppose that this is correct, right? So what we want to do is we want to construct a very simple piece of code that if we give it the temperature in centigrades, it returns to us the temperature in Fahrenheit. So we will do 9 by 5 times C plus 32. Simple, right? So now if I run this, actually I should not have run this, I should do F. So 100 degrees C is equal to 212 Fahrenheit. Okay, this is a very simple conversion. But let's suppose that you're writing a long piece of code and you have to do this same calculation over and over again. So what do? I mean, in this case, the code is very simple, but it could be a very complicated piece of code as well. So what you will do is you will describe this entire thing as a function. So how do you start doing that? I would have said surprise, surprise, but anti-surprise, because to create a function, you don't write function, you write def, right? And what are you doing? So you're converting centigrade to Fahrenheit. So what I will do is I will construct a name. It could be anything. It could be temperature conversion, but as I said, having meaningful names helps, right? So I will say that this is the name of my function. The def keyword actually tells Python to start declaring the body of whatever I'm going to write as a function. And then all I have to do is I have to do the same thing. Now,
Sorry, just one question. So def, what does
yeah.
it mean again? Is that naming the function
No.
or
Yeah, no, that is a way of declaring a function or defining a function.
okay.
So def is
Okay.
basically you're defining. So when you use for, you use for. When you use if, when you construct a function, you use def.
Okay, thanks.
So now what will happen is that so whatever is calculated inside the function, you have to return it outside. So you will use the return statement and just say return f. Okay. So when I run this, nothing happens. Okay. What has happened is that this function has been created in the memory of Python in this local instance. So until you restart your notebook, that function will always be there. So wherever you are in the piece of code that you're at, you can just do. So when you write CEN, you will automatically see that there is an autocomplete coming up here, right? So when you do this, what will happen? So can someone tell me what the answer of this would be?
Will it be 212?
Can you tell me why it will be 212?
Because previously you already assigned C to be 100.
Does anybody else have any other thoughts? No? Yes? Maybe? Come on, don't be shy.
I get an error message, but it's name error, so
Okay, so at this point, I would like to introduce something called variable scope. So a function is a modular unit, and it does not see anything that is happening outside, and it does not affect anything that is outside unless you return something from it. So while Elson said that we had C declared here up here before, this C is not visible here. Even though we're declaring the exact same variable, this value is not passed here, right? In order to pass a value inside the function, we must use the input arguments here. So what I will do is, and also the function can be anywhere in the code and be able to be called anywhere in the code. So because it could be at the top and you would have declared C here, then this C would not be visible here. So what we will do is we will modify the code. We will say that we will pass it an input argument, call it C. We will then use the same variable down here, convert it to F, then return, and then. So when we're calling the function, we have to give it a number. So let's suppose that we pass it 100. What does it return? Oh, because I did not run this. Yes. So what did it return? 212. Why did it return it? Because we asked it to convert 100, which went to the function, became the value C, was used here, calculated F, and then F was returned. So when we run this, the value of F that is calculated will be returned here. If you do not trust me, let's increase this to 200 and let's run this again. And because it's it is a linear, I don't know, adding 100 does not increase that by 100, but it becomes 392 because of this ratio here. So now we have a function. Okay, this requires a little bit of a mental leap. So I'm happy to explain this again if something is not clear. Please do not hesitate to ask. We can, if something is not clear, I'll be happy to explain it again.
I have a question. What's the meaning of the return F mean in the function?
So to best understand this, let's remove this altogether. If I remove this, if I calculate it, if I then run send to far 200, what happens? There is no output. So it runs the function, it gives it 200, it is calculated on the inside of the function, but it never becomes visible here. In order to bring the value out, I must return it from the function to the outside, and then when I run it, it will display it. Does that explain what return is doing?
Yes, thank you.
Perfect. Okay, so what I want to demonstrate now is we are going to see what, so if outside, I'm going to create a variable called F and give it the value 100. But note that this 100 is written, oh, I actually forgot to explain this. When you're creating data types, I told you that you can have a string data type and you can have a variable, you can have an integer data type. The difference between the string and the integer is not the math itself. It is how you are passing the data. If a mathematical number is included inside inverted commas, it automatically becomes a string. So just to demonstrate here, I'm going to create a variable f and give it the value 100. Okay. If I now calculate send to far 200, which is basically me asking it to convert, you will notice that inside f is being calculated, right? And that f is being returned and that is being printed here. So if I do this, it returns 392, which means that inside the function, the value of f was calculated as 392 and returned. So if I ask my Python, what is the value of f? What do you think it will return? I need an answer.
The string
It will return the string
100
100. Why will it return that?
because that's what you assign in.
No, but
in
I
that.
ran the function after that, right?
But the f in the function doesn't read whatever that's outside.
That is correct. So this goes back to the concept of variable scopes. What is outside, what is inside. And for anything on the inside to be passed outside, it has to go through the return statement. Okay. Now, how do I access it on the inside? How do I change the scope of the variable? So when I use the word scope, there are two scopes. There is something called global and there is something called local. So by default, things have a local scope, which means that things inside the function and things outside the function, things inside the function will be local to the function itself. Now, in order to change the scope of the variable, what do I have to do? Actually, I haven't told you, so I shouldn't expect you to know this, but I will use the keyword global. Actually, now I'm confusing languages. So, okay, let's see if this works. So if I do global f, yes, if I rerun this, and then if I go down here, I declare f, and okay, this is probably a bad idea because we're actually overwriting the value in here. So let me comment this out. And instead of doing this, let's do return f plus f. Okay. And this is an experimental thing. I have not done this before. I don't know if this will work or not, but let's see. So even though I'm passing the number 200 to the function, what is the function returning? Let's find out. The function returns 100, 100. So what is happening? When you declared global f, the function knew that somewhere outside the function, there is a variable called f, and I have to go find it and find out what the value is. Then in this part, because the value is 100 and it is a string, just like we did this, and CompBio, it will add 100 to 100 as two strings, and it will be returned as 100, 100. Okay. So this helps us understand that if we did not do this, if we did not declare this, and if we then ran this, it would have given us, oh wait, what? Oh, because I'm not overwriting it. The scope has still been declared, so I need to change this. Yeah, now we're back. So if I had not declared the f value as a global, it does not come in. I mean, it was probably a very bad example, but yeah. So let's go and double check this with ChatGPT, and then we will close the session today. Show how to create global variables in Python. So you can declare the scope of the, it doesn't have to be inside the function. It can be anywhere in the code. but we're gonna ask ChatGPT how it's doing it. So it's declaring global variable, I'm a global variable, and then it's printing it out and calling it. But whatever is declared on the inside will not be accessible. So, I mean, probably haven't prepared this, so I don't know exactly what prompt I should type in. Show how to differentiate. No, create global variables inside the Python function. So now it's showing you how I did it. So you have a function body here. It could be any function. You declare the global variables here. But because these are now global, in the other function, you can still access them. Okay. Does that make sense? I hope it does. And I haven't confused you even further. But the idea with functions is that you have to keep an eye on what the function takes in as an argument. It is always safe to pass the variable that is going to be used inside into the function, and then only get things that you want out of it. So does anybody have any questions? Are we clear on if conditions, for loops, and functions? All good? Okay. So remember that these few things that we have talked about, which is data type, data structures, and if conditions, for loops, and functions, you can do almost everything by combining these things. So you can have for loops inside functions, you can have if conditions within for loops, you can have both a for loop and if condition inside the function. It depends on what you are trying to do and how you are trying to do it. Okay, so we're coming to a close of today's session. We have covered up till here. For the next one, I would recommend that you install Anaconda. But if you have not, that is also okay, because we can do these things inside the Google Colab as well. And I will demonstrate how to read and write files. And then we will start using advanced libraries. Two of them are important. One of them is NumPy. The other one is Pandas, which is required for data science applications. So if you want to do machine learning, if you want to do any kind of analytics, depending on whichever field you're in, Pandas is a very powerful framework which will allow you to do those calculations, and we will run into those. And in the last session, we will do both reading data from files and then plotting them and changing plotting styles and looking at plot formats. So I would like to leave this on the note that, remember, you do not have to remember the syntax. You just have to be aware that something like this exists, so that when you need it, you can actually go online or go to ChatGPT and ask for it. So I will be here for another 15 minutes. If anybody has questions, please stay back. I will now stop the recording and take any questions that you might have. Any questions? Otherwise, please feel free to go leave the session.